Hey everyone! Thank you for joining us for the December session of the AI Apps and Agent Dev Days series. My name is Anna. I'll be your producer for this session. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our speakers for today. Thanks so much for joining.
All right. Thank you very much, Anna. Welcome, everyone, to the third episode of the AI Apps and Agents Dev Day series. Got lots of really cool stuff we're going to be looking at today, really focused on the scaling and orchestration of AI agents. So before we get started, my name is Stephen McCullough, and I'm an AI solutions architect with NVIDIA. So that means that I get to work with Microsoft on implementing all of the latest and greatest AI technology into Azure. And I am joined today by Anthony Shaw.
Hey everybody, my name's Anthony. Great to be here again, and present some stuff with you this morning, Stephen. I'm calling in from Sydney in Australia, and I lead the Python advocacy team at Microsoft.
Yep. Thank you, Anthony. So a bit about this program. Microsoft and NVIDIA are super close partners, and they work together to power the next generation of AI through deep integration of our technology into Azure. So this webinar series is part of that integration. We want to show users like you how you can best leverage all of this amazing technology that's coming out. So definitely make sure that you tune into the series and explore all of these great integrations that we have to show. So without further ado, let's go jump into it. So today we'll be covering a couple different things. The first is sort of a recap on exactly what AI agents are and how they work. Of course, that's going to be sort of the core topic of this episode. So we want to make sure we're going into this with a robust and refreshed understanding of it. Next, we'll go into Microsoft Agent Framework, which is essentially a tool you can use to orchestrate and tune and build your agentic workflows on Microsoft's tool and on Azure. Next, we'll go into NVIDIA AI blueprints, which are essentially reference recipes and architectures that you can deploy yourself or you can use to customize and fine-tune for your own purposes. I'll show you a custom example of the AI model distillation blueprint from NVIDIA. And then Anthony's going to take us through some real-world integration examples showing how you can integrate your agentic workflows into your app, into your customer-facing apps, as well as background batch processing. All right, so first thing, AI agents, right? Let's have a quick recap. So what are they? How do they work, right? Well, I imagine that if you're attending this webinar, you are at least a little bit familiar with large language models or LLMs like ChatGPT or Nemotron or DeepSeek. But what exactly is an agent, right? Where's the difference between LLMs and agents? Well, you can think of an agent as an LLM plus memory plus reasoning and tools. Many LLMs nowadays have native reasoning and tool calling support built in. So once we add that memory layer on top, that's managed by agentic software, like Microsoft Agent Framework, we can turn that LLM into an agent. So if an agent is essentially an LLM that has tool calling, reasoning capabilities, and memory capabilities. So those three real functional capabilities that we add into the LLM open up a whole world of possibilities and allows us to do amazing things with our LLMs and with our agents. So from a high level, right, what can this agent do? With the tool calling, essentially it's calling external code. So you can pass in, let's say, a Python function that updates your LinkedIn, or JavaScript function that will create a web page for you. The possibilities for the tool calling within agents is, really, like, your imagination is the limit. So there's lots of amazing things that you can do. And whenever we think about the reasoning, right, that's essentially the recursive prompting that's happening inside the LLM that allows the LLM to become more intelligent and have much more intelligent, reasoned outputs. So agents are capable of incredible things whenever we add in this reasoning and tool calling capability. So whenever we think about agentic workflows, that's essentially putting multiple agents together to work to combine together and accomplish some specific task that we assign it. So a common question that we get is, why would we build this agentic workflow and introduce this complexity instead of having, let's say, some uber intelligent agent, some uber intelligent single model to do all of this work, right? Well, the reason for that is specialization. There's really not a single AI model out there that is the best at everything, right? We haven't hit artificial superintelligence just yet. So we need these specialized, fine-tuned models to accomplish individual tasks that they were really trained for. So for example, some AI models like Nemotron Parse are really specialized for document analysis. Some models like GPT-5 or Nemotron are more chat agents with coding capabilities. Some models are great for audio processing. So most of us probably have experience with these chat models, but there's really a whole world of different LLMs out there that are meant to accomplish particular tasks. So whenever we use them together, we can really get the best of all worlds. We can get the best document processing capability, the best audio visual capabilities, the best chat capabilities all together into one system. So for example, you can think about, let's say, an AI system that might be used by doctors during a medical diagnosis. If that doctor brings in, let's say, their phone connected to this backend AI system, that backend AI system needs to have the capability to transcribe and understand whatever the doctor and the patients are saying in this diagnosis room. That workflow also needs to have the ability to look up past medical history of the patient. And it also needs to have the ability to do deep research into the symptoms that this patient is listing and associated diseases that this patient might have. So all of those capabilities are really important for this hypothetical, medical agentic workflow system. And rather than having one, super intelligent model try and do all of these different things at the same time, we see much better results whenever we have an agentic workflow comprising multiple models all working together to achieve that task. So now that we know about agents and agentic workflows, the big question is, okay, how do we run these agents? How do we build these workflows in an effective, efficient way? And that's where Anthony is going to jump in and tell us about Microsoft Agent Framework. Take it away.
Thanks, Stephen. Yeah, so Microsoft Agent Framework is something that we released in preview a couple of months ago. And at the Ignite conference just last month, there is several workshops and showcasing of the Microsoft Agent Framework. So Agent Framework supersedes two other projects, one called AutoGen and one called Semantic Kernel. is designed as an open agent framework that works on the Microsoft stack and also others as well, and I'll cover that off in a bit. The main thing is that Agent Framework is a code-based agent builder. So, you would either use Python or C#.NET to develop these agents. And I guess the question is, like, there are drag and drop editors for agents. So why would you write it in code? I think the main thing is that you've got absolute control and the ability to customize everything in the agent. So, like Stephen says, an agent basically is a combination of an LLM, like a model, with memory, tool calling, and reasoning. But a lot of the time as well, you want to integrate other things, like you've got MCP calls, you've got specialized APIs you want to call into. You want to kind of have a lot of control as to what comes in and what comes out of the each individual agent in your workflow. So Agent Framework gives you that ability because you're writing Python, so you have full control. It's a open source product as well, so that is MIT licensed. So for any companies who are concerned about having proprietary code or anything like that, we have open licensed it. Another great thing about it, which I'll demonstrate at the end of the slides, is that you can run it locally and you can experiment locally. So you can even run it with local models. So if you're running some models locally on your machine, or you want to experiment with something like GitHub models, which is free, you can do that. And then when you're happy with how the agent works, you can get it running on Microsoft Foundry. And then the other thing as well is that it is an open framework. Obviously, it does support Azure and Foundry, but it actually supports other clouds as well, and I'll demonstrate that later. Next slide. So Agent Framework is one option, but we have several different ways of building agents on our platform. If you have your own framework or you've got another one that you prefer to use and you just want to run those applications on Azure, we have infrastructure as a service, so you can run that as either a container, which is kind of the modern way of doing it, and the way I would recommend is that the agents are run in container environments, and you would deploy those onto something like Azure Kubernetes Service or Azure Container Apps. Then that would be the IaaS option. So you can basically take any open source agent orchestration framework, and you can run that on Azure. We have full support for LangChain, for example. If you go on the LangChain documentation, there's a Microsoft section in there that lists how you can integrate LangChain into every Azure service that would be used for agents with LangChain. Any other tool and framework as well would support the models on Azure or can be run on Azure. So the team that I work on does a lot of work with those open source projects to make sure that we're well supported in the different frameworks. If you prefer something where the platform is doing more of the management for you, so that's sort of platform as a service, AI Foundry and Agent Service does that for you. So you can just do a sort of ClickOps based agent. So you're just giving it a prompt, giving it a model, and you just basically create an API endpoint and call it from there. You don't need to write any code. The PaaS option is AI Foundry and Agent Service. So you can build agents just fully in Foundry without writing any code. And you can plug in knowledge sources, you can implement basic memory patterns and things like that. And you can also integrate tools with MCP servers as well. So yeah, I'd recommend checking that out if you don't have a dev team. And then our fully SaaS option is Copilot Studio, whereas with Copilot Studio, you're mostly looking at building agents for like users within your company. Or if you're a vendor that actually sells that sort of thing to other Office 365 users, you can use Copilot Studio to do that. So you're building an agent that's used for like employees and internal users to do specific tools and capabilities. And next slide. Cool. So Agent Framework is our open source engine for building and orchestrating intelligent AI agents. Like I mentioned, it is built on open standards. It's designed to be interoperable with different models, different storage for memory, different backends. We're doing a lot of work to make sure that Agent Framework is something that doesn't have any lock-in, you're really kind of building on an open base, and then you can integrate that into any different model, any different cloud, and any different backend. We also have a team at Microsoft Research that's looking into like the cutting edge ways of running agents and feeding some of those insights into agent framework. So anyone who's interested in AI research and agentic research, you'll see a lot of papers coming out from the Microsoft Research team, and some of those ideas and technologies are being built into agent framework. Also, it's ready for production, which is something I'll explain what that means later. But just because the scale of Microsoft and the types of customers that we have, have very high expectations as to what a production application looks like. We put a lot of thought into things like security, into telemetry, into deployment models, how to make it resilient, things like that. So, yeah, next slide. Cool. So if you're building, so for a single agent, an agent has capabilities. It has, I think, sorry, skipped a slide.
Yeah, sorry about that. That was my bad, Anthony. Okay. There you go.
All right. Okay, cool. So a single agent has a model, memory, tool capabilities, and often, like Stephen said, you want it to have like a single purpose. So you basically drawing boundaries. This agent does this task, and it specializes in that specifically. With Agent Framework, you can build different types of workflows. Where I would recommend everybody starts is a sequential workflow, where one agent hands off to the next. So you have a basic agent which has a purpose. You give it that purpose in its prompt. You give it the tools that can only help it do that one thing, nothing else. And then once it completes its tasks, it gives its output to the next agent. So when you're designing these things, if you think you need a multiple agent workflow, and often actually you possibly don't, modern models can handle multiple things at once. You can give them 20 different tools, and you can give them a fairly complicated list of instructions, and they can call those tools and just complete a single task as a single agent. If you feel like you definitely want more control over what each agent can and can't do, you can put them in a sequence as a sequential workflow. Because agents can take a few seconds, sometimes a few minutes to complete, depending on how big the task is. Often you also want to have that concurrent. So instead of them running as a sequence, you can kind of initialize a workflow, send it to multiple agents all work on the same thing at the same time, and then you can consolidate those results back. We call that a fan-in, fan-out pattern, and I'll give you one example of that later. We also have handoff, where the agents can actually, you fan out to different agents, but they can also send information to each other. And then the ones after that, the bottom three in this graph, are really more advanced, and I'd recommend only exploring those once you've done the top three. I've met a lot of people that have got really excited about the idea of having multiple agents where they're all talking to each other and coordinating and things like that. Like in theory, sounds like a brilliant idea. And then when you actually test it out in practice, they can spend several minutes running and having conversations with each other, getting confused, or you can use just a huge amount of tokens in the conversation. And so I strongly recommend starting off with a sequential workflow. If what you think could be sped up a bit, then look at a concurrent, so fan out, fan in, and then really only if the problem that you have needs like a group chat or a Agentic pattern, then start to explore that. But I'd only recommend doing that once you've explored the other options first. I wouldn't suggest going straight into that, because you really need to have a lot of knowledge about developing prompts and how to kind of refine the prompts and the tools down so the agents don't get stuck in an infinite loop. Next chat. Next slide, yeah. So yeah, an agent without tools is not an agent. It is really just another chat interface, and you're just talking with a model. So the whole point of this agentic framework is that you give it capabilities to actually go and do things or retrieve data to make decisions. And so what we've done with Agent Framework is we've enabled it so it can talk to anything that uses one of the open standards. So A to A, agent to agent, MCP, or whilst it's not a sorry, I could confuse that. the OpenAI spec is not a standard, but it's actually becoming like the sort of standard API interface for most models these days. So we support anything which has like an open AI interface. And then we also support a huge number of different backends for storage retrieval, for function execution, and even different clouds as well. So Amazon Bedrock would probably be one name that jumps out there. Yes, it is a competitor platform, but it's something we can also integrate into. So like I said before, we're not really designing something that's designed for lock-in. We just want to make an open framework that works really well in Azure, but also can be used on other platforms. Next slide. Yeah, so with agents, there's a lot of information you can provide in the context or in the prompt. But ideally, especially if it's a chat agent and a user's had a conversation with it and they start another thread, they don't want to have to remind the agent about things that they've previously talked about. So what we kind of have built into this is the idea of a memory or a conversation state where we've got a process which kind of like summarizes the conversation and then stores it in a memory pool. And that memory pool can then be retrieved and injected back into the agent for another thread. So if you have a conversation thread with an agent, which is the chat agent, and you talk about your plans, what you were working on, and then you start another thread with that agent, it basically can have a longer term memory where it's remembered specific facts, and also it's summarized previous conversations. So it's actually aware of decisions that have been made before, so you don't have to explain everything all over again. That pattern is an open implementation. The example we're going to use, the code example, just uses it in memory, so it just stores the memory in memory, so just in RAM. But you could drop it in Redis, for example. You could drop it in a structured SQL database. That's just the standard API. So depending on where you want to put that information, obviously security is like a massive concern there, because if it's got information that the user's given it about what their plans are, what they're thinking about, whatever it is, then you want to store that somewhere where it's secure and only available to that specific user. And so we offer that as like an open spec that you can implement. So if you've got your own proprietary database, you can lock it into that. Or we've got example implementations with SQL databases. Next slide. Cool. Yeah, and then lastly on Agent Framework, this is designed to be enterprise ready. So when you run a workflow in Agent Framework, you can enable tracing. All that tracing is then available either locally, you can see the full traces in DevUI, or if you connect it to Application Insights, you can see the full trace for every conversation and every agent. And you can see exactly what decisions it made and why, which tools it called, with which parameters, how long it took, if there were any errors. So we've basically got a full audit log of everything it was doing. That again is built on open standards. That's built on open telemetry. So if you have a different tracing provider that supports open telemetry, you can also export it there as well. Cool. So I'm going to give you a quick demo before we jump in. And how to build an agent. And to do this, I'm going to use an extension for VS Code called AI Toolkit. This one is, if you go and look in VS Code and go to extension store and search for AI Toolkit, you'll see this one here, AI Toolkit for Visual Studio Code. That's the extension you want to install. And once you've got that extension, you'll see that there is a AI Toolkit menu. And once you open that up, you go to Agent Builder. Agent Builder is kind of just a way of getting you started building your first agent. So what you do is you connect in the different models. So in my case, I've connected to my GitHub account, so I can run any model that's on GitHub. I've also got it connected to Foundry, so I've got GPT-5 Mini running there, and I've also got 5.4 reasoning running on my laptop. And I can actually run the models directly on your machine. So if you're running Foundry local, you can run Foundry local models and just develop the agent locally. You don't need a cloud provided model. So once you've done that, you give your agent a name, you pick a model. It also works with Olama, so if you can connect it to any local model, you can do that. You give it your instructions. You would set up then any tools. So tools are things that it would connect into. These could be custom tools, so it's a piece of code that you've connected it to, or an MCP server. So in my case, I've got 2 MCP servers, which are related to my application. I've already got them running on my machine. So I'm running them in here. This is my architecture. I've got a API and I've got 2 MCP servers. One is the finance MCP and the other one is the supplier MCP. And these are connected to proprietary databases. This is all custom code. But these are MCP servers that are running locally on my machine, and I can just design my agent by giving it some instructions. And then in the playground, I can give it a prompt and it will run the agent locally. And then it will, if it does decide to call MCP tools, I can see which tool did it call and with what parameters, and then what was the output. So for example, in this one, we're analyzing the performance of products in this fictional store. And I wanted to understand the top selling products for a specific store over the last few weeks. And I wanted to use the MCP tools to do that. So basically, it's going to retrieve some information. And so in my conversation, I said, I'll look up store number 1 for the last 3 months. And then I want you to use the tools to look at revenue, units sold, and SKU. So it's going to use GPT-5 Mini to do that. And I can see that it's actually run, the agent has called out to my MCP. It's fetched some information about the products, and it's given me back that result as JSON. So I could ask it for a text summary instead, but in my particular case, I wanted this back as structured data. So my agent's actually retrieving information about like which are the highest performing products that I want to use. When I'm happy with the agent, in the agent builder, I can go down to the bottom and do view code, and then I can pick Microsoft Agent Framework and Python, and it would generate the Python code to basically run my agent. So if I want to turn this into an agent framework script, I can use this as a starting point. So it's basically generated all the code I would need, and I can look at this and customize it and then start to integrate that into my app. So yeah, that's kind of how you would get started with Agent Framework. You can either jump straight into the code, or what I'd recommend is getting AI Toolkit to connect it to some models, give it some instructions, give it some tools, and then just kind of experiment with the prompts until you're happy with it. Yeah, back to you, Stephen.
All right. Thank you, Anthony. That was awesome. Yeah, so Anthony did a great job showing us how we can create these agentic workflows using Microsoft Agent Framework. But if you're anything like me, you know, the question is, how do I get started, right? Where do I look? What can I reference if I want to build some sort of agentic workflow for either my personal experiments or for my job? The answer to that is NVIDIA AI blueprints. So these NVIDIA AI blueprints are essentially reference architectures, reference workflows that you can deploy yourself. And they're all open source. So you can go in and tweak and edit them to deploy them however you would like. So for example, if I wanted to take the RAG blueprint and plug in my own models that I wanted to, it really wouldn't be difficult to do that. I'll show you the GitHub repo in a second, but it's all open source, so very easy to customize for your own deployments. And the way that these blueprints work is that there are 3 foundational blueprints that NVIDIA has created. The first is Agentic AIQ blueprint. The second is the RAG blueprint. And the third is the data flywheel blueprint. And then on top of these blueprints, we've created other blueprints that are more specific to particular industries. So for example, a healthcare blueprint that's focused on RAG, or a data flywheel blueprint that's focused on the financial services industry. And if you go to build.nvidia.com/blueprints, I don't know if my screen is too small to see here. I'll zoom in a bit. But you'll be able to see all of the different blueprints that we have available. So for example, AI model distillation for financial data. Also, the AI observability data flywheel. One that we'll be showing next January, as maybe this will be a bit of a teaser, is the Agentic AIQ blueprint that I mentioned. So very powerful blueprint. I recommend you check out that episode when it comes in January. And yeah, we have lots of blueprints for all different industries and use cases. So, I mean, if you're looking to develop and deploy your own agentic workflow for whatever industry you're in, there's a pretty good chance that NVIDIA has a blueprint that is either, maybe just what you're looking for or pretty close. And since it's open source and really made to be configurable, you can go and configure it and deploy it yourself. So it's very easy to get started here. So if I go back to, let's say, this model distillation for financial data, if I want to view the source code on GitHub, I can just go here and it will take me to the Jupyter notebook that contains all of the source code associated with this workflow. And in this workflow, it has the entire orchestration that you see here. So I'll zoom in a bit, but yeah, it has this entire orchestration all within this Jupyter notebook. So all of the databases, all of the models, all of the NIMs, and the surrounding orchestration software is all built into this Jupyter notebook. So really, really easy to just get set up and get going really quickly. And this particular blueprint is focused on model distillation. So essentially where you're taking a larger, more intelligent model and using that to fine tune a smaller model for a particular purpose. So let's say we have a 50 billion parameter model, and we want to train a 1 billion or 3 billion parameter model for a very specific task, like summarizing stock data on the public stock market. That's a great example for where you might use this blueprint. So this notebook takes you through the entire process of how you can get up and running, and you really just click to complete all of these different code sections, and it just does the entire thing for you. So it's really just awesome, and it tells you all of the requirements you would need for any individual blueprint. So for example, for this one, you would need 2 NVIDIA GPUs, A100, H100, or if you somehow have a B200, you're a very lucky person. And so, yeah, just two of those GPUs, and then you can go ahead and deploy this workflow. So really easy to get up and running with these blueprints. And it's just a great way to kind of get your feet or get started, get your hands dirty, get your foot in the door with agentic orchestration. So let's take a look into how these different blueprints work, right? So for example, I talked to you about the model distillation workflow. And in this case, we're using the Llama 3.3 70B, of course, a 70 billion parameter model, to fine tune these smaller models. So everything from a 1 billion parameter model to 49 billion parameter. And they're being fine tuned on financial data. So everything from financial news that you might find in, let's say, the Financial Times or Yahoo Finance. That's what it's using to fine tune this model. So let's look a bit more under the hood at what's going on inside these blueprints. So what you'll see a lot of in these blueprints is NVIDIA's own open source homegrown LLMs. So the latest one actually just came out yesterday is the Nemotron 3 Nano. These are all under the Nemotron AI family. So the Nemotron 3 Nano is the smaller member of the Nemotron 3 family, and it's a very powerful LLM, really seeing great results in our internal benchmarks and great results over the past 2 days after its release. We also have the Llama Nemotron Super and Llama Nemotron Ultra that are just sort of going up that chain of size and intelligence. Also for vision language models, information retrieval, and content safety, like I mentioned earlier, there's no one super like uber intelligent model that can do all of this stuff very well. So Nemotron aims to really provide all of the models that you would need in a fully open source method, so you can run the agentic workflows that you need. So there's still the question of, okay, now we have the model, but how do we run it? And there's something called NVIDIA NIM, which is essentially a Docker container that comprises your model and different observability microservices, different optimization, inference optimization microservices as well. And it's all built into a single Docker container. And it makes it really easy for to deploy and run an AI model. So if I go back to my browser and I go to catalog.ngc.nvidia.com, it will take you to essentially like the home base for lots of NVIDIA software. If you go on containers and scroll down, you'll see NVIDIA NIM. And from here, you'll see all of the different NIMs that we have. So for example, there is the Meta Llama 2 70B chat model. So that's a container, like a Docker container with a Meta Llama 2 chat model baked inside and optimized and included and baked in with other observability microservices. We also have, I'll show you the Nemotron 3 one that just came out. So if you want to go ahead and, try these models out for yourself, this is a really great way to get started. You just run like Docker run and then the container address here, and it spins it up for you. The only thing you'll need is an NGC account. So if you come back to this website and create an account and get an API key and include that in your Docker run command, you'll be able to spin it up, very easily. So lots of great stuff going on. NVIDIA really makes it easy for you to get started and get up and running with your AI models and your agentic workflows. So now that we know how to get up and running and get set up with our agents and our models and our workflows, Anthony is going to show us how we can integrate these workflows into real-world user-facing applications.
Yeah, great. Thanks, Stephen. So I'm going to kind of lead on from where we finished before, which is that I showed you how you can use the agent builder to experiment building an agent. Then what you can do is you can take the code that it generated. In my case, it's going to be Python, but you can also use C#.NET as well. And I basically developed a few different agents. And these agents are designed to provide some like weekly insights to store managers in this sort of fictional store app that we have. The code for this application I'll share at the end of the presentation as well, if you want to download this and have a look to see how it works. So before that, I'm kind of building one agent here, but I've actually built several agents in this particular case, and I've given them names. So we've got one which looks at the sort of weather forecast for that region, one which looks at events, and one that's the one we were kind of building before, which is looking at top selling products. So we've got those 3 different agents. Then what we do in Agent Framework is we have a workflow builder, and we give it a name and a description. And then we say, what's the starting point? So that's the data collector. So that's the one you initially give the instructions to. And then we add the fan out edges. So we say, okay, a data collector goes to a weather, an event, and a top selling products. And then we have fan in. So those things come back. So these 3 agents then consolidate back into an insight synthesizer, which is fun to say. But the synthesizer agent basically is the one that takes the results from all the other agents and then turns it into like a single response. Once I've built this agent, then I kind of just wrap it in a Python function. What you can do in Agent Framework, actually, which is pretty cool, is you can run this thing called DevUI, which lets you visualize the workflows that you've made. So the one I was just showing you before, the code for that, you can actually visualize that directly in a browser, and then you can also just run it directly. So instead of having to write scripts and stuff to test this out, you can just iterate on it and run it in the browser. And then any events that happen, like whilst that's running, will pop up and be shown on the right-hand side. So you get all the traces, and you get tool calls and anything like that would be shown on the right. So what we have basically with this weekly insights is we want the ability to run the workflow, see what's happening, and then get that back directly in here as well. Something else we can do is in the Foundry agent, we've got a local visualizer. So instead of, in the Foundry extension, there's a local visualizer. So if you wanted to see this information bit in VS Code, you can use that feature in the extension as well. So what I've done is then taken this code. This is the workflow that we've built, this workflow object in Python, and we can actually just run that workflow from code directly. So sure, we can run it in DevUI and we can experiment and stuff like that, but I actually want to integrate this into the application because I think that's a lot more realistic as like an example. And when we're building this application, I kind of gave a glimpse before, and someone in the chat asked for some more information on this. This is Aspire 13, which was shipped, October 31st. Actually supports Python as well now. So what I've done is basically define my application architecture in Aspire, and I'm running this all locally. And so I've got an API, and the API then can talk to the different MCP servers, and I've got a web front end as well. So my shop is running as an app, so I can click on the link, which again the table. I can click on the front end, and I can see the shop. And this is actually running a Python API. I've got the agents and the workflows that I defined before in DevUI. I've imported those into my application. And if I log in as like a manager, then I can see and it can run the insight. So this workflow is now the one that was running. That's not working today. We were migrating some stuff yesterday. That's why it's broken. But I can see all of that information, and then in Aspire, I can actually go and get logs and stuff like that, and I can see what's happening. I can go and look at that trace and understand exactly why it broke. So I use Aspire because this is just a really nice way of me defining an application that has multiple components. So I've got the MCPs, I've got the API that hosts all my agent framework application workflows. We deployed a production version of this as well, which is up here. So in our app, I've logged in as a store manager, and it's actually run that workflow that I was talking about before, and it's given me a nice like integrated output. So this is an example of an agent that's not like a typical chat agent where you've got to start a conversation with it and say, please, can you tell me about important things happening this week? The way we designed this one is actually that the weather, the events, and the top selling products would be run for a particular store. So in this case, we've got the pop-up New York Times Square store. And so we've run the workflow and said, okay, I want you to only look at it's fiction. This store doesn't exist, but in a fictional scenario, like, are there any major events happening in Times Square this week that a store manager might need to be aware of? So we're going to search the internet and see if there's any like parades or anything happening that the store manager might need to be aware of. Is it going to be really cold? Is it going to be raining? Like, should we stock up on umbrellas? Like, what other things might be happening in that particular store? And then also in that store, like, what are the top selling products that the store manager might be aware of? So like, they can see that over the last few weeks, here are the top selling products. We've sold 63 pullover fleeces. And the interesting thing is that when I run the workflow, the output of this is not just text, because we can get it to output markdown. That's fine. But then the user's actually got to read that and understand it. And we're just outputting long paragraphs into our interface. What we want to do instead, and what you can do with Agent Framework, is when you're building these workflows, so this synthesizer agent is something that we've defined. And in code, we've said, okay, it takes weather, events, and product analysis. Like, it takes all this information and it actually outputs this class that we've defined called the Weekly Insights class. And this is a model. It would say, for this particular store, here's a summary, here's the weather, here's the events, and here's the stock items. And these are actually a list of objects. So where previously you might build an agent that gives you text output and then the user's got to read that information, what we do instead with Agent Framework a lot of the time is we define these classes, these types, and then you have structured information in there. So when the agent runs, it actually gives you back a list of stock items to the API. It gives you back some specific actions that you can take. It gives you back insights as a list that you can render in the portal. So in the UI here, like, if I wanted to make it so that this was clickable, so I could click on that and it would take you to the product, that's really easy for me to do. And I don't need to write all this kind of weird code that needs to like parse the text and kind of guess where the links are and stuff like that. So with Agent Framework, my strong recommendation when you're building these agents is that you think about whether it is you need actually structured output. And where AI agents are really capable is where they take something which is unstructured. So you've got like paragraphs of text, or you've got inputs from users. It can take unstructured information, it can make it structured, and it can make decisions on that, and it can make suggestions on that, and it can summarize the information. And then you can get that information back in a form which is unstructured as well. So the other option we have is we've got this inventory agent, which is something we've built. And I'll show you what that looks like in here. It's this one. This is a nice simple one. Yeah, it basically is a single agent that is orchestrated by a second one. And our suggestion here was that we've got a number of items in our store catalog that are low on stock. And we wanted to help the store managers basically figure out how do I restock them. So this is one where we can launch this particular agent, and let me find it. This particular agent has been given a set of instructions. So we've got a summarizer, but we also have one that will go and fetch as much information as it can about the stock using MCP tools. And once it's got that, it will fetch the information. Oh, I'm not having much luck today, am I? It will fetch the information and to give you back some recommendations as to stock priorities and things like that. So yeah, that's another one we suggested. The code for this, again, is in the repo. And like I said before, my suggestion is that you start off building a simple agent in Agent Builder. Once you're happy with that, you turn that into code by going to the bottom and doing view code. And then once you've got the code snippet in Agent Framework, you can then convert that into an actual workflow by creating a workflow builder, deciding which pattern you want to use from the slides we had before. So either fanning out and fanning in, or having a sequential sequence. And then for each of the agents, you would then basically define a set of instructions and the tools that it has. And then once you've done that, you can visualize it in DevUI. So that's the insights one. You can visualize it in here, run it in here, experiment with it until you're happy. And then you can see the events and traces and tools on the right-hand side in DevUI. And then once you're happy with all of these things, you can basically compose this into a container that can be run either in Foundry or it can be run on any kind of container compatible platform. So that is the feature of the AI Toolkit and the Foundry extension, is that once you've built a workflow for Agent Framework, you can actually turn this into like a deployable application container, and you can have that running on production infrastructure. Cool. Back to you, Stephen. Back to the slides.
Yeah, I mean, I think that was the goal. That was it.
Okay,
I think
cool.
yeah, there's like amazing stuff that we have covered, and I mean, it was all really interesting, highly technical stuff. And I think that the next step for everyone in the audience is to go and try to do it yourself. So right here, I have a QR code that takes you to a Microsoft blog, which shows you how to run an agent yourself using Microsoft Agent Framework. So this is probably the best way to get started. It's the sort of hello world of using Microsoft Agent Framework. And it's really great. This is what I use to get started, to get familiar with Agent Framework. So I'll leave it up here for a bit so you can go check it out for yourself. There's lots to explore in this world. In this AI world. There's been a banner going under the screen to join the NVIDIA Developer Program. Yeah, there it is. So definitely join that as well. Lots of cool resources through that program. So definitely check it out. And our next episode coming up in January is focused on one of our other NVIDIA AI blueprints. It's focused on our deep research agentic blueprint, really focused on sort of like fully automated RAG system that can handle all different kinds of data, and you can deploy it super easily. So it's definitely something that you should check out. Whether it's applicable to your job or maybe it's something you're interested in personally, there's lots of value from this upcoming episode. So definitely check it out. Stay tuned. Lots of stuff coming through the series in the future. So yeah, thank you. Anything else, Anthony?
No, that's all. Thanks. Yeah, thanks very much, everyone. I'll drop a link to the code that I was demonstrating as well, if you're interested in how that was put together.
Awesome. Tony Baloney. Love it.
That's my username.
Such a good username.
Too late to change it.
All right, everyone. Thank you so much, and take care.
Thanks, everybody.
Thank you all for joining, and thanks again to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.